Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the C++ for Java Developer series. In this episode, we're going to discuss the solution of the logger. We are going to talk about compiler options, and I will show you where you can find the different compiler options, and we'll go over a brief explanation of some of the key compiler options that you often use. And then lastly, we will talk about installing Visual Studio and sort of explore the beginning features. I know I said this was going to be about make and pre-make and CMake, but that episode was just taking too long, so I decided to split it up into two parts. This is basically going to be the Visual Studio part, discussing why we need a build system, and then in the next episode, we will go over pre-make and how to use that to build a file. Anyways, let's start off with the logger. Okay, so basically, I wanted you to build something that looks like this. This is actually a macro that expands to this, and if we run this, then you can see we get this executed from /main.cpp on line 9, and it prints out the log and a number, which is what we have here. And this is line 9 of main.cpp. So how did I do this? Well, in log.h, we have this pragma once. Then we have this macro, which takes in a string, which this is the format string, and then it takes in a variadic argument. And you can see that it calls this function log internal, which passes the file, the line, the string, and the arguments that were all passed in, and they just forward it to this argument. Now, the one tricky part that you may have encountered was this VA args and taking in a string as a parameter. So you can take in a string as a parameter by using a const char star, which is a const char pointer. We'll talk about that in a future episode. And you can take in an ellipsis as a variadic argument. Now, in log.cpp, we have the implementation of this, and this was also another little bit harder part, but if you looked up Stack Overflow, you should have been able to solve this pretty easily. And so basically what I do is I take all of these arguments and then I say print the line and the number that we got it from, then print a tab, and then you have to do this weird thing, which I never remember, and I honestly Stack Overflowed this, okay? And you can basically just say VA list arg pointer, and then you can get the start of that, which is starting here. And then you can do a vprintf, which will print everything in here. And then you can say va end arg pointer, and that should do all the things that you want it to do. So a little bit tricky. If you didn't get that, don't feel too bad, but that was the solution I came up with. And if you came up with something else that works, that is just as well. Okay, so one of the things I want to talk about is if you were developing this, you may have noticed that it does get annoying to constantly update this build.batch file, right? You constantly have to add in a file. If you add a new file in, then you have to add in the OBJ, the object file, to link it properly, and you have to update this, and that is a hassle and error prone because oftentimes you won't remember to update this, and I don't blame you. I don't remember to update this, okay? So we'll talk about in the next episode how to set up a build system to do all this automatically for us. Now, I want to take a look at some of the common compiler options real quick that we can add on to these commands just to see what they do. So I have just Googled the MSVC compiler options because we are using the Microsoft Visual C++ compiler. If you're using GCC and Linux or Mac, you would look up the GCC compiler options and they will be very similar. But basically, we have this page, which I will have linked in the description, and I will also have the GCC compiler options linked so you can take a look at those. And if we go ahead and actually look at the, let's see, the compiler options listed by category is probably the best thing. So if we take a look at this, here we go. This is really cool. We get, okay, so this is the optimization compiler options, right? We can do /O1, which will create small code, so it optimizes for space. We can do /O2, which creates fast code, so it optimizes for speed. /OB, which controls inline expansion. That's something we can talk about in the future. /OD disables optimization. This is deprecated. And so you can basically see we can go through all of this and sort of look through what this does. Let's real quick just type in /O2, which should create fast code according to this. So if we go into our build file, and these are compiler options, so they go into the first phase, right? The linker options would go into here. So if we just say do /O2, you'll notice that it should compile correctly still. So if we build, you see we still get it built, and then if we do build or bin/main.exe, it works just the same. Basically, the compiler may have just outputted different binary format, which is optimized for speed. So for instance, this might remove functions that aren't used. And you can typically combine this with other optimization ones, right? So you can say favor small code, favor fast code. You can mix and match some of them. Some of them don't go together, and it will warn you typically if you're trying to put two together that don't go together. This next section talks about code generation, all right? So all of these things generates different types of code files, right? So let's take an example. We have so many different things here, okay? Most of the time you won't have to take a look at any of these, but it's good to know how to find them if you ever do need to find something specific, okay? I'm gonna look for something. Yeah, I'm probably not going to actually show any of these off because it doesn't look like we have any in here that would be particularly interesting. I've never used any of these on purpose. So yeah, output files specifies basically the different outputs you have, right? We're using one of those in the linker /out to get a specific file name. But right here, we can see that if we do /fa, it basically creates an assembly listing file. So I believe if we go into our compiler, and let's just go ahead and we'll do /f lowercase a. Let's build this and see what we get. So if we go build.batch, okay, so it compiled fine. And let's see if we got an extra file in our intermediate. And we did. Okay, so this is really cool. So if you want to see what your compiler is compiling it to, we can open up main.asm, which is assembly. Now this is the assembly code that was generated, and these things will look very weird. This is because of name mangling, but these are just function sort of pointers, right? So this is our main function. This is our log function, right? This is saying we have an external function here, and it just mangles the name and everything. But you can see this is where the real meat of the program is, right? This is saying push the variable 10. And where is that coming from? Hey, we have a thing right here, 10, okay? And then it says push this offset. So it's basically getting our log function pointer. Then it's saying push 9. Let's see if we can see. Not sure what the 9 is doing, okay? Then it gets another offset. So we're going back into the main function. It looks like pushing that so that we can return to it. And then we call the log function here, and then it does some fancy footwork here, probably to get back into the main function. Okay, so this is the assembly generated. Now, one of the interesting things, if we close out of here real quick, and then we change our compiler option, we take out O2, what you'll notice is we'll get assembly that's much closer to what we wrote. So if we run this one more time, this is the cool thing about compiler options, right? If we go back into main.asm, there we go. Look, this is actually a lot more readable. See, we even get, look, this is a log, here is a number. So that's literally what we printed, and that is probably in the read-only section of our program. Then we get our main function, and we get this push move, which is, it tells us this is coming from line 8. So if we look at line 8 of our code, that's this thing. Sorry, not that one. That is this thing right here. So this is entering the function. And then if we look at this, this says this is line 9. So we push 10. We get the function pointer, we push 9, we get the function pointer, then we call log internal, and then we do this thing. So you can see that this follows our code a lot more closely. And if you wanted to recompile the O2 version and notice how many lines of assembly are removed, that's because it's optimizing them away. It's doing more stuff at once. That is sort of the magic of the compiler. So if you ever have any doubts, compile with assembly on, or use Godbolt's Compiler Explorer, which you can Google and learn more about that. Check out the link in the description as well to see what output you are generating. If you're really concerned about speed and want to know if the compiler will optimize something away, look and see if it does. Okay, we have several more compiler options. We have things for the preprocessor. Okay, so you can see that we have just several different things. Here's a useful one. /d defines constants and macros. So what this means is you could basically go, hey, I want a constant macro that's going to be here. I'm compiling on Windows, so I could say /d, and then if you just go Windows, all caps right after the /d, an interesting thing will happen. Watch, if I go #if define Windows, and we've gone over macros, so we know that this is basically going to look for a macro called Windows. So if it's defined, we will log this. It's grayed out, but really what's going to happen? Let's see. We'll build it, we'll clear the screen, and then we'll run our executable. Look at that, it still logged it. Why did it still log it? We didn't define Windows in here, but we did, okay? Because we defined it inside of our batch file using this preprocessor or this compiler option. So you can do global defines for compilation throughout this, which makes it super useful if you want to set things during compilation rather than in your code itself. This way you can set things for, like, if I'm on Mac, define a Mac thing. If I'm on Windows, define a Windows in each of your build scripts. Okay, and then you can see there are several other ones here. You have language. There are several options here for the language. Some of these /z are kind of useful because they have to do with things like generating PDB files, which are debug files, and so on. And then we got linking options, okay? You'll notice we use this one, /link, which says to link the files. And we have several different options we can use here as well. This sets the stack size. So for instance, if you ever run out of stack memory on your program, you could technically increase this using the stack linker option. And you could read more about that and basically give yourself more memory to work with. So lots of cool things that you can do here. These four are specific MD, MDD, MT, MTD. These are useful when you are working with libraries, which we'll talk about in the intermediate series and how these work, what's happening here, because they are very important. Look, you see this, and I'll talk about why it's so important that these have different things. And I have run into errors where I had differing options when I shouldn't have, and it has crashed my program. So we'll talk about that in the future. And you can read up on all these different options, try them out. I'll talk about one more, warning levels, okay? I usually go with a /W4, I think W4, W3. So if we go /W4, I bet you we will get some warnings. So if we type that in and we go ahead and say build.batch, nope, looks like we didn't get any warnings. Cool, we wrote perfect code. Let's go ahead and make something warn us, okay? So if I say int my variable equals, and then I'll do a float here. So I'll say 30.0f. We will probably get a warning because we're not casting here. So if we go ahead and say build.batch, there we go. We get these warnings. We get 2 warnings, okay? So first of all, it says we're converting from a float to int on line 13. So it's warning us, hey, you didn't cast this. You didn't say int to cast it. So that's good. And then another thing it warns us about is it says my variable is initialized, but it's never used. Also useful. Watch what happens if we turn off warnings. Okay, if we turn those back off, we say build.batch. We don't get warned. We don't get that information. So always, always, always compile with a /W4 is what I like to do. And if you ever have a warning, it's warning you about something, and you're like, I know this is fine, you can turn it off, right? So you can do /WD to disable a specific warning, right? So if we do this again, okay, I know I'm not using this. I don't want to be warned about this, right? What if that's true? Well, you could do /WD, and I can't remember if you include the C there. So we will go /WD, copy, paste that, and let's actually look at the documentation, see what it says real quick. So yep, so it just says do /WD warning. And if we, okay, right here, so it says NNNN. So we only have 4 characters, and see how it shows us an example. It says /WD suppresses C4326. So we don't actually have to include that C here. Now, if I do this, notice we were warned of 4189 here, but if we build again, we no longer get that warning. We just get 4244. So if you ever want to disable a certain warning, you can do that, but always compile with a higher warning level. And if you want to go even higher, I usually don't do this, but you could. You can do -W all, which will warn you of everything. Okay. That is it for compiler and linker options. I just wanted to go over that real quickly so you knew where to find them and you know how to use them and look at the documentation and implement them. Now, let's move on. Visual Studio. I will have a link in the description. I've put this off, and I didn't show you this initially because I think that if you don't want to develop using this giant application, I completely get that. And that's why I wanted to show you how to develop with Visual Studio Code, just so you don't have to immediately use this to follow this tutorial. This is a very big application, but it is very useful. It has things that can let you profile your code, so you can find out which lines exactly are taking the longest. Really useful. It has a memory debugger, so you can see, look directly into the memory of your code, see what the memory looks like itself. Super useful. It has a very helpful debugging. You can step through your code. So there are so many features in this, and you can get the free download here. I would recommend just clicking this. Using the defaults, you should be good. Tell it you're using C++, and it should basically install everything that you will need. We'll take a look at it and sort of set up the same project we have here and see how it all works, okay? So I'm going to go into Visual Studio. I'm going to try and go through this pretty quickly too, because I can see that we're already taking quite a long time. So we'll go ahead, and you may or may not be greeted with the empty scene. That's fine. I'm going to hit a new project, which you would also click if it greeted you with like, this is a new thing. Then up here, I'm just going to say I want to work on C++, all platforms console. I'm going to do an empty project, which should give us like basically just regular code. You will get a console, so don't worry about that. Let's call this practice project. We're going to mirror our own thing. You can choose the location. I'm just going to leave a default because I really don't care about this right now. But you can change the location if you would like. We'll hit create. I just realized my mouse capture was off for the first half of the video. Sorry about that. But anyways, once your project creates, first thing I would do, click this button over here. This basically switches your project from a weird fake view of folders. Like you'll see we have folders, but these aren't really folders. And it will switch it to actual view of what your file system looks like, okay? Next thing I would do is I would say add a new folder, which we get since we're in here. I'll call this include. I'll add one more new folder. Right click here. We'll say add a new folder. We will call this a CPP or source, whatever you want to call it. Then I'm going to go into here. We will hit add new item. And I will just call this main.cpp. We'll click CPP file. That will create it, open it up over here. Then we're going to go ahead and create a new file in here. And I am just going to call this log.h. All right. Then we'll go back into CPP and I'll add one more item in here and we will call this log.cpp. Click on CPP again. The one difference that it does when you click on CPP or H, if you do H, it generates the pragma once for you, which is nice. Okay. Then I'm going to go ahead and just copy the code we have. So I'll copy all of that, paste it into log.h. I will copy all of this in CPP, paste it into the CPP file. We'll do that as well. Then lastly, I will copy everything in main and I will copy that into main. And we're getting an error here. That is just because we don't have an include directory set. So this gives us a perfect opportunity to look at the properties of our project. Right click your project, hit properties. Now we have so many properties in here. Okay. I highly recommend take a look through it, sort of mess around with them, see what they do. Most of them correlate directly with what we were doing with compiler options, except it's just in a GUI form. First thing we're going to do, we'll go to C++, expand that and hit general. Under additional include directories, hit edit, then browse for a folder, which you can do by right clicking or clicking the three dots there. I'm going to say include this include directory. We'll do all that, hit OK, hit apply. Now this error should go away. Okay, and I just spent the last 10 minutes looking at this. This is why I hate Visual Studio, and this is why I usually don't build projects this way. Okay, why is this not working? We turned on the include directory, but it's still not working because if you look here, we have this listed for debug x64, which is the thing we changed it for. But if you look up here, we're in debug x86. Change this to 64, and now it magically works. I don't get why they designed it this way. I honestly don't. This is just the epitome of stupidity. Anyways, if we were to run this, hit the green button up here, we'll launch this in debug mode. It runs, it executes just fine, except we don't have this definition. Well, how would we do that here? Well, if you click properties again, and we're in the right debug platform, well, you can see here, if we go to C++, we have a lot of the same things that we had before. Let's click on a preprocessor. And then look at this, it says preprocessor definitions, and it automatically gives us a couple debugging console. Let's open this up. And I'm going to add one more. You can literally just do a new line and I'll say Windows. Now, if we hit OK, hit apply, this turns purple. We now have this defined. So if we run this again, then you see we get it logged out and then it tells us to press any key to close the window. I will show you one last thing, then we'll sort of be done with this. If I hit a breakpoint in here, very easy to debug. Hit the green button. We are stopped at this breakpoint, okay? And you may or may not have this window open to the right. Most likely it looks something like this. This tells you sort of how the process is running, how long it's taking, how fast it's going. You can click memory. You can see the actual memory in the program, what it looks like. We have a bunch of question marks because we don't really have any memory. You can click modules, which may not be there by default. Tells you what DLLs you have loaded. So much useful stuff in here. And then you can hit F10, skip over this line, hit F10, and run through your program and go step by step to see what's happening. And you can see here that it basically just ran the program again. If you want to run without debug, you could hit up here, I believe it's run or something. Let's see, debug, start without debugging. Okay, so you could click this, which is Control F5. That's usually what I do. So if you just run Control F5, it will run it without entering debug mode, which is a little bit faster. Anyways, that is it. Very brief introduction to Visual Studio. We will be using this in the next tutorial because, as you can see, it makes working a lot easier. You don't have to manually add these files. It does it automatically. But we'll talk about using a build system to even more automate this so we don't get annoying bugs like this thing where you couldn't even realize that it was starting up with the wrong configuration because you had no control over that. We'll look at all of this and fix this using Premake to sort of streamline our process just a little bit more. I hope you guys enjoyed this tutorial. If you did, please hit like and subscribe. And for the challenge, this isn't really a challenge, but look through the properties over here. Go through these, see how they relate to the compiler options we were clicking. C will be compiler options. Linker will be linker options, and you can see what it generates here. This is what it generates, which is absolutely massive. Look through the different things that you can do, mess around with it, see how it relates to the options on the MSVC compiler options website. Okay, that will be it for this tutorial though, and I'll see you in the next one where we talk about build systems.